Hello, everyone. First of all, I would like to thank everyone for joining this workshop. My name is Hakan. I work as a machine learning solutions engineer at Arize. And today, for this workshop, I will be talking about integration between LangChain and Arize, specifically monitoring and fine-tuning flows for your LLM agent. So yeah, let's get started. So first of all, what I want to talk today throughout the agenda is I want to first start with like a brief intro to LangChain, like what LangChain is and what it tries to do, and then talk about what an LLM agent is. And then after that, kind of do a brief intro on LLM observability, like how does it work? And then after that, I'm actually going to jump into a collab after just showing a few slides. And we're going to actually code together an LLM agent, build it from scratch, and then actually monitor it with Arize. So you will be able to see how to build an actual LLM application to production, and also how to monitor it real time with Arize. So before jumping into like what an LLM agent is, I want to kind of talk about LangChain itself. I know most of you probably heard about LangChain, but LangChain is basically a framework that empowers users to develop their own large language model applications. And then LangChain itself provides different modules, as you can see here. And most of these modules are models, basically the large language models such as OpenAI's GPT models, the prompts, so it can help you like implement prompt engineering workflows with prompt templates, indexes and memory. So basically you're storing different type of context-specific data that you might want to use within your agent. We will be leveraging indexes today, specifically vector stores. Chains, meaning like different chain of LLMs, interconnected chains that kind of interact in a logical sequence to kind of accomplish a specific task. And then finally, agents. And agents is kind of like the most complex module of LangChain. It kind of encompasses all these models together. And it basically enables users to generate responses more efficiently by creating a series of interconnected prompts and responses in a logical sequence. So let's look at an example on what an agent is. Like, so for example, like I have this agent, I ask like, who is Leo DiCaprio's girlfriend? What is her current age raised to the 0.43 power? So when the agent starts executing itself, it basically tries to find the next best action in order to kind of accomplish the task, which is this answering a question. And then here, like for example, it says the first action is to search, and the input to that action is Leo DiCaprio girlfriend. So the agent is trying to answer the first question. And then it finds the answer by searching the web. And then it says, okay, now I need to find out her age. So then we see another search action where the input is to find Camilla Moron's age. And then you have an observation, 25 years. So to kind of finalize everything, the last thought is, I need to calculate 25 raised to a specific power. And then now the next action is calculator. And then by using the action input, you have the final answer, 3.99. And then the agent provides the final answer. So here, what you see here is the agent understood what the task is, kind of broke it down into specific prompts that are in a logical sequence, and then executed them by selecting the best action to take and by using different tools. These tools could be like searching through the web, doing the calculator, it could be something else. So in this way, the agent basically accomplishes a very complex task. So this is kind of an LLM agent looks like. Let's say you actually deployed an LLM agent into production, but then the next step is to kind of have some observability in place, because the way observability works is that it kind of enables you to detect issues of your large language models in production, and then makes you troubleshoot, improve your models by doing prompt engineering or fine-tuning. And if you look at how does LLM observability work, like we have our foundational model single LLM here. So you can think of this as like a chat GPT, and you can accomplish different tasks. Like this could be question answering, translation, summarization. This could be literally anything. But the most important thing is the model itself has an input, and this input is kind of labeled as a prompt. So this could be like summarize the following document, answer this question, and then the model outputs a response as well. So these prompt and response pairs kind of represent the input and output of large language models. And then you can also like record response length, prompt length in terms of tokens, different steps, API delay, metadata, conversation ID. So you can record all these, but also the most important thing for an observability workflow is also to have embeddings in place. You can generate embeddings of your prompt and response pairs so that you can actually see the internal representation of data in different like lower dimensional spaces and take actions. So how does this work? the way it works is like you have your prompt response pairs recorded from your LLM agents, and then you can kind of visualize them in a lower dimensional space. Like you can think each of point as like a specific embedding, and you would actually see that different embeddings will be clustered together in this space. And those embeddings that are clustered together will actually kind of like be semantically similar. And these embeddings can actually kind of represent different things. Like it can be responses about like a specific product. It can be questions about like, I don't know, politics. So it will be very different on the task you are trying to accomplish. But if you actually have an observability workflow in place, when you have these embeddings generated in an observability platform, they will actually kind of try to detect different misleading responses, inappropriate or rude responses, or like responses where there's like negative user feedback, so that we can actually analyze these responses and improve your prompt engineering workflows. Like here we have like misleading responses, prompt and response pairs here. By looking into the prompts, you can analyze the prompts and kind of improve them, do a little bit of even A/B testing to see which prompt actually gives you better feedback and less misleading responses. But here the goal is to kind of alert the users that something might be wrong with the response or the prompt that's given or outputted by the LLM. And here, like we actually have like an example here. Like we have, let's say I'm an end user, I'm interacting with a LangChain agent. My prompt is San Francisco, the capital of California. And then here the response is like every well-educated person knows that Sacramento is the capital of California. So here I actually have a rude response, and I would get an alert here because you would actually see a cluster of points that are kind of rude or not expected together, like that are semantically similar. And if you actually apply observability for this workflow, you would get alerted from this issue itself. And then you can take the right action. You can kind of write a new prompt saying that your tone should be not rude, or you can like fine tune your model with context specific data. It really depends on the task, but the goal is to be able to have some sort of alerting and detection in place so that you can take the next action. So this is kind of how observability works in a sense, but let's actually do this like in a real life example. Let's actually build an LLM agent from scratch, and then let's actually monitor it with Arize. So for that, I'm gonna actually jump into a Colab in order to actually code this all together, this product documentation LLM agent. If you should actually see a Colab link, Xander shared it on the comments. And then if you click on the Colab, you should see something like this. And then I definitely recommend you to copy to Drive so that you would have your own copy and then you can code in it. Like for example, I have my own copy here. Again, we're gonna try to code this today. And then we're gonna go through the steps and then monitor it into Arize. So let's actually get started. So I wanna kind of spend some time within this architecture that we're actually gonna code today. So what we're gonna code today is, we're gonna create kind of like a product documentation chatbot. So the way it would work is that a user, whether there's a chat history or not, will ask a standalone question, like a new question, and how do I create an account? And then by providing the documentation of a specific product, we expect an answer that will be generated for that specific product that we provided the documentation with. In this example, we're actually gonna use Arize's product documentation, feed that to an LLM agent, and then ask questions to get answers about Arize. This could be about data ingestion, Arize's specific functions, monitors, observability workflows. And the way this specific architecture works is that you have your documentation. This is my Arize product documentation. You would first convert that into text by loading it, and then you would split the text into chunks. So think of your documentation in small chunks within a specific format, and you're gonna use those chunks to create embeddings, which will be stored in a vector store. So the goal is to first create a vector store of embeddings of a context-specific data. And then afterwards, we're gonna take our question, it's gonna go through an LLM, we'll have a standalone question, and then we're gonna create an embedding for the question itself. Then we're gonna search across the vector store, kind of do like a similarity search to find the most relevant documentation in order to compare with the question. So if the question is about how do I create an account, the vector store is gonna search all the documentation and find the most similar embeddings that might actually be relevant for this question. And at the end, the vector store will output the relevant documentation, and you would have a standalone question and a relevant documentation together, like a prompt. And then we're gonna feed it into a large language model, say that, okay, here is a standalone question, here is the relevant documentation to answer, provide a final answer. And then the large language model itself is gonna create an account It's going to provide an answer in order to how to create an account. So let's actually try to code this together. So first, just a heads up, it's very important that you actually have some sort of OpenAI API key enabled if you want to run this core app. I already ran it with my OpenAI API key, and you can actually get it from here. It's also in the links. You just have to create a new secret key, and it will be available for you. You can copy it and paste it here. So next, after installing necessary dependencies, which is mostly Arize, LangChain, and OpenAI, we kind of import the necessary LangChain document loaders and different libraries. And then the first step is to load documentation data and split into chunks. So here we have our instruction: use LangChain documentation to load Arize doc data from GitHub. And if you go into LangChain documentation, what you would actually see is here, you would actually see different indexes. If you click on the specific indexes, you're going to see document loaders, right? So I'm going to go ahead and find Gitbook here. Here I have Gitbook. And then you can see that I can download any path, all paths from a given notebook. And you can kind of select any kind of document you want. So I'm going to copy paste this into kind of like a loader. And now I'm going to run this. I'm actually not going to run this because I already saved it as this all pages data. So I'm going to skip this. But because this takes like 5 minutes to load, but you can see that it's already fetching text from like docs.arize.com. I just need to change this to Arize. And then it's basically fetching all the data available on Arize documentation into a specific variable. And then we can continue. So the next part is to kind of define a text splitter function and split loaded data into chunks of 1500, and then define a vector to store using Facebook AI similarity search into a variable named DB. So what we're gonna do here is, I mean, this is kind of like a vector store that I chose. You can choose any vector store, is to create a vector store. So let's look into the LangChain documentation. So you would see that the vector stores here, right? So I'm gonna select a vector store. I'm gonna select this face, which is Facebook AI similarity search, but you can use like Chroma, that's also very common, or anything else. And then when I click on this, I already see some examples. Like this notebook shows me how to do it. Like I already have text splitter, splitting docs into chunks, and then embeddings, and then creating the vector store. So let's first copy the code for text splitter itself and post it here. So I have chunks of 1500 here, which is S. And then I'm just gonna add like a small code here, kind of like a separator. The goal of the separator is to separate this data for each new line, because that's kind of how our documentation is structured within Gitbook. And then it's asking, like, it's saying this doesn't exist. So I can actually see that the variable I have is all pages data. So let me actually answer that. All pages data. And then I'm actually gonna run this. And then right now I have docs, which is splitted text into chunks of 1500 from the Arize documentation. So just want to kind of stop here a little bit, talk about this part. So we wrote this code that loaded documentation into Gitbook, then split into chunks. The next place is to create embeddings and create a vector store to store our embeddings. So as I said, if you look at this documentation, it's actually very easy to get this. Like, it's just 2 lines of code. You would actually create embeddings. So I'm actually gonna paste that here. I use OpenAI embeddings, and then I create a database, which is my vector store from Facebook AI similarity search. And then I have my docs, which is here, the splitted chunks, and the embeddings. So I'm gonna run this. And right now, this is basically creating the vector store. If you don't have your OpenAI API key, this will not run, just as a heads up. And then finally, I have these 2 lines of code, which kind of gives like some metadata to the vector store and assigns a toolkit. So the toolkit is basically like making sure that you have all the tools available within the vector store so that you can interact with. I'm just gonna run this. And then the final step is to initialize the LLM agent. But before initializing the LLM agent here, which is the agent executor, we need to kind of define an Arize callback handler. So what this Arize callback function does is it integrates LangChain and Arize together. So when you pass this Arize callback, which is here, into the callback manager, whenever you run a large language model in LangChain, the prompt and responses will be automatically logged into Arize. So whenever you log a new application in production, anything that your users actually will ask a question for, any prompts and any outputs the large language model gives will be logged into Arize, and your observability workflow will be enabled. Here we have like Arize callback handler from LangChain documentation. You can also check our docs on how this works. We have an example collab as well. But the way Arize callback handler works is that on every prompt and response generation, we just log it using our Python SDK. So I'm going to define our Arize callback function here. I'm providing a model ID and a model version. This is kind of to generate a name of the model that you will see on Arize, and now you need to find your space key and API key. So if you haven't signed up for Arize yet for free, please go ahead and sign up. Well, you will actually be able to access your space settings here, and you can copy and paste your space and API keys into this collab. I already did this beforehand as an environment variable, so I'm going to actually run this. And right now, what happened is I set up my Arize client within my agent. So this line creates my agent, where it creates a vector store agent, where for a large language model, I'm providing an OpenAI model with a specific temperature, and the callback manager is tied to Arize callback function. And then I also have my toolkit, which is my vector store that I define here. So now we are actually ready to test our LLM agent. So we need to come up with a standalone question to ask to the vector store agent so that we can get information about Arize. I'm just gonna start with a very simple question. The question would be like, why UMAP over TSNA? So Arize also uses different algorithms to kind of visualize the embeddings in a lower dimensional space, and then it uses UMAP. So we can just ask, like, what is the reason Arize uses UMAP over TSNA? I want to be as vague as possible. Do not want to use Arize because I want the agent to go in and find out why Arize uses this. So I'm running this. So as you can see right now, it's entering a new agent executor chain, meaning right now it's generating embedding vectors. So Arize automatically generates embedding vectors for you because we are integrated with it. And then look, the agent says, okay, I need to find out why UMAP is preferred. Action, go into Arize doc store, the vector store, and then it already found an observation. And now it's generating the final answer. Again, we're generating embedding vectors and prompts here. And then the agent says, I now know the final answer. The final answer is that UMAP is generally faster than TSNE and preserves more of the global structure of data, while TSNE focuses more on local structure. And if you actually look at Arize documentation, this is kind of very similar, almost exactly what Arize says to answer this question. And we can ask like different questions as well. We can ask like, what kind of monitors does Arize support? So Arize is an observability tool. We know that it supports machine learning model. So I'm just going to ask, what kind of monitors does Arize support? The agent will go in, say that, okay, my next best action is to go into Arize doc store, search for it, and find the relevant documentation to answer this. And then it says Arize supports managed monitors, custom monitors, and programmatically configured monitors, for example. And then it generates that specific output for me. And then as you can see, whenever we do this, embeddings are being generated for prompt and responses, and they are successfully logged into Arize. So at this point, we have actually coded this whole thing within literally like 10 to 12 lines of code, thanks to LangChain. And now, because of LangChain and Arize integration, we can actually have observability enabled for this whole workflow. So I'm going to actually show you how that looks like. So I'm going to jump into Arize, where I already have sent like hundreds of Arize-specific questions here. And then this is our UMAP. The goal of UMAP, as I said, is to kind of visualize the embeddings in a lower dimensional space. And we also apply clustering on top of it, not only visualizing, to kind of have some sort of insights available to the user. Like right now, the model itself, the clustering algorithm found two clusters and correct them here. We have this cluster and this cluster. So let's actually see what this cluster is showing. So right now, we have like 6 points here. It says like, what is a prediction identifier? How is embedding drift calculated? How do you generate your own embedding? What is an embedding? Again, what is an encastrement? So again, it's all about embeddings. You can see that we have like some question about predictions and embeddings kind of in this one. So this is one of them. The other one is like, as you can see, we're like a cluster that's far away. So let's actually check out what this looks like. So when I look at this, interestingly enough, you can see that it's in a completely different language, but it's still about Arize. I still see the keyword about Arize, but this is in French. So what I see that is some users ask questions in French about Arize, but then what the agent did is it still went into Arize documentation, found the right answer, and provided me a response. And this is my kind of French responses. So you can see that even if it's in a different language, it's still answered. But when you go into your observability workflow, you see that there are completely different clusters of data. So in your own LLM application, this could be like your cluster of misleading responses, inappropriate responses, or like, let's say, responses with negative user feedback. And you can even like color by different stuff here. Like Arize already kind of looks at token usage. Like here, you actually have different tokens here, colored by different token usage. So you can kind of analyze it based on how much metadata you kind of send. But at the end, the goal of Arize is to make sure that you're able to detect new clusters, interesting clusters of data. Like, for example, this is a data within a different cluster. And as a next step, you can actually download this cluster and then kind of use it, analyze the prompts, and then improve your prompt engineering workflows. So what would happen is, like, let's say you have a misleading responses, which are here. You can download this cluster and then try new prompts to see if that actually gives you like better user feedback. Another point that you can actually do with Arize is you can set up like different monitors. So here, like I'm going into my monitors tab. I can create like a new drift monitor. And then here, if I select my feature, let's say we're looking at response embedding, I can actually track the Euclidean distance. Let me quickly zoom out here. I can track the Euclidean distance for the feature, which is my response embedding over time, so that I would get alerted whenever like the embeddings themselves drift. So what this would mean is that whenever a new cluster of data comes in that's not expected, or whenever like I have like rude responses or some new response coming in, I would actually be alerted. And so that I can actually go in, take the next best action. This could be like you're fine-tuning your model or actually like prompt engineering your model. But at the end, the goal is to kind of have some observability in place specifically for your LLM agents. So this is kind of what you can do in terms of embeddings. And then you can always like set baselines. Here you can see Euclidean distance over time. You can even filter your embeddings by specific features, by specific tags. Like here, we actually have the prompt embedding. And here you can actually see how the prompts themselves look like. If I look at this part, for example, like you can actually see what LangChain uses as prompts. Like it first starts with, you are an agent designed to answer questions about sets of documents. You have access to tools for interacting with the documents and the inputs, and then provides the relevant documentation and the standalone question to answer. So within this workflow, you can actually kind of find out what's actually available for you, how you can use LangChain and Arize together to kind of have like a complete set of LLM operations, LLMops tools, and you can always get alerted whenever something goes bad with your models. So that was actually kind of it for my workshop. I would like to thank everyone again for joining and listening. I would love to answer some questions if there is any about this topic. Let me stop sharing my screen. Okay. I see only one question. Is LangChain used here for the same purpose as Llama Index? Yes, it can be. So it really depends on what your task is. Like LangChain is not only used like for question answering specific indexes, but the goal, what we did here today was to index a set of documents, specifically Arize product documents, and then kind of use LangChain to answer questions. You can definitely do that like with a tool like Llama Index. But I would say that the agents themselves is more like a more powerful tool, because in this case, I only provided agent with a specific tool, and that tool would be the vector store of Arize. But I could have provided like 5 different vector stores. I could have provided documentation about all the MLOps tools there are, and then the agent would actually find which tool to use based on the question or based on the task. So it would actually kind of try to find the best action to take. In this case, it was just a Q&A answering agent based on the specific vector store, but you can actually provide a wide array of tools. Like in the first example I showed, there was the example about Leo DiCaprio's girlfriend that actually used different action tools, which is like search functions, searching the web. and then also the ability to kind of compute mathematical functions. Okay, let's get another question. Are there any limitations or potential drawbacks to using LangChain and Arize together, especially when it comes to scalability or ease of use? This is a great question. So I would say the main limitation and potential drawback using LangChain and Arize is actually, I would say, the limitation of large language models. Like right now, as you know, there's like a token usage limit within especially OpenAI's models. And when you actually have like too much documentation, or if your chunk size is too high, or if you send too many requests to the OpenAI API, it will actually fail. I actually had that experience myself when I was figuring out with something. So I would say that's the main limitation, the limitation of the language model itself. But in terms of scalability, I don't see any problem, as like most of the observability platforms like Arize are built for scale. So it actually could handle any number of prompt and response pairs. And then finally, in terms of ease of use, that would depend on the task. I would say like having like a specific user interface that's very easy to understand, like ChatGPT, would be very helpful to have here. So kind of think of like you're interacting with ChatGPT, but whenever you have a prompt response pair, they're actually being logged into Arize, so that you can actually see what users of your large language model application do, how do they interact, and then they can always give feedback, like a thumbs up or thumbs down, so that you can understand like the different clusters that led to a thumbs down. I hope that answers your question. Let's jump into another one. Other use cases for this integration: chatbots, voice assistants, or automated conduct. Yes, so LangChain itself is very powerful that there are many different use cases. Like this could be personal assistants, autonomous agents, chatbots. You can query like tabular data, specific database systems. You can like write some LLM agent to understand code and summarize it. Or you can kind of interact with different APIs, such as search APIs. So any type of use case that you want with a large language model should be possible with LangChain. And as long as it's possible with LangChain, it will be logged into Arize as an observability workflow. So because Arize is always integrated with LangChain, as long as you use a large language model, which is the whole point of LangChain, you will actually have observability enabled, because all the prompt and responses and their embeddings will be automatically logged into Arize. Awesome. I don't think there are any other questions. So yeah, thank you so much, everyone.